Lewis structures are used to represent valence electrons in atoms and molecules. Valence electrons are the outermost electrons in the atom. So they're the electrons that are in the highest energy level. And these electrons are important because they are what is responsible for bonding, which then is associated with chemical reactions. So for atoms, the Lewis structure is simply the element symbol surrounded by dots that represent the valence electrons. Now we can use electron configurations to figure out the number of valence electrons, or more preferably, if all we need to know is how many valence electrons. For the representative elements, or also they're called the main group, the number in front of the letter A represents the valence electron. So for example, 1A down here, this 1 is the number of valence electrons for that group. So lithium would have one, or has, not would have, lithium has one valence electron, so we would just place one dot. Now underneath it on the bottom, I have written the valence electron configuration, so you can kind of connect it to the s and the p orbitals. Now it doesn't matter which side you start the dot on, so I just started it on the left. But what we do imagine the element symbol is to have like a box around it. And we're only going to put 2 dots or 2 electrons maximum on each side. And so the total number of electrons, valence electrons, will never exceed 8. Okay, because there's only 4 sides, so you can have maximum of 2. Now, if you look at my next column, beryllium, and I just want to demonstrate something because in part, I don't want you, as you're learning, to get confused when you see small variations. But once you get more than 1 valence electrons, there's 2 ways to draw Lewis structures. Personally, for what we need to do, I don't mind which way. If you took more chemistry, perhaps your instructor would like you to do it one way over the other to help you understand what you're learning at that time. But this is the 2 ways. So beryllium has 2 valence electrons. It's in the 2s2. So one way would just be to go around clockwise. And so I would just draw 2 dots, one on the first side, and then I'm just going around clockwise, so then I'd put 1 on the top. The other way would be to put the first 2 electrons together, almost like an orbital box diagram. Remember, S has 1 orbital and the electrons go there first. And then the P sublevel has 3 orbitals. And when we fill those orbitals, we go 1 at a time, and then we pair up. So the second method is you first put the first 2 together. Now let's go, and you'll see eventually the 2 methods kind of merge together, but I still want to show you this. So then I'm going to boron, which is in group 3A. So that would have 3 valence electrons. So in the first method, they would just go 1, 2, 3. We just go around in 3. In the second method, you'd put the first 2 together like they're in the s orbital, and then you'd put the p here. So it looks like that. Then carbon has 4, so in the first method it would go 1, 2, 3, 4. And then in the second method it would go pair 1, 2, whoops, awful, that's almost 2. Okay, 1, 2, and then 3, 4. So then it doesn't keep pairing it because if you recall in the p orbitals, they go in individually. So then nitrogen in either way would go 1, 2, 3, 4, 5, which would look the same as if I put the first 2 together and then 1, 1, 2, 3. Oxygen would be 1, 2, 3, 4, 5, 6. Fluorine would be 1, 2, 3, 4, 5, 6, 7. And then neon with 8 is max, so it's going to have 2 on each side. Like that. Now, once I hit nitrogen, I didn't have 2 different ways because actually they would look the same no matter how you were filling them. So it really would only look different in the group 2A, 3A, and 4A. Again, personally, what I'm looking for on Lewis structures of atoms is that you get the correct number of valence electrons, which would then mean the correct number of dots, and you only can put maximum 2 on each side. Okay, so if you think of the little box around the element symbol, there's a maximum of 2 dots on each side, equaling at some point 8 if you're in the noble gases. We will learn more about Lewis structures when we learn about covalent bonding and molecules.